Welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistics, PIC, Shop Monkey, and Fifth Third Bank Motorsport. I am Francisque Savignan, the founder and CEO of EPARTRADE, the global platform for the performance and racing industry. This is episode 333. And we're going to be talking engine performance with MAHLE Motorsport. This morning with me are Judy Keane, the co-founder of EPARTRADE, and a wonderful host, Mr. Brad Gillie. Judy?
Thank you, Francisque, and thank you everybody for joining us today. Yes, we have 5 great sponsors on today and all throughout the year, but MAHLE Motorsports is one of those great brands that everybody knows. And Joe Maylish over at MAHLE was one of the first brand suppliers that jumped on board and is using this platform. Excellent. He just continues to put new content on the platform, keeping it full and getting responses. So very grateful to Joe, and we're proud to have him on board as one of our first suppliers. And he's coming on board right now. So Brad?
Awesome. Thank you, Francisque and Judy. Really appreciate that. Thank you, everyone, for tuning in. As always, before we get started, I definitely want to remind you that if you have a question, they're not always are not only welcome, but they're also encouraged. So please feel free to type a question in the chat at any time during the webinar, and we'll certainly ask our panelists and get a good answer for you here. The interactivity of what we do here at Race Industry Now is certainly a key to helping continue to make these even more successful as this continues to grow. Well, today's topic, the advantages of modern piston rings by MAHLE Motorsport, and joining us is Joe Maylish, program manager, and George Wright, application engineer. Joe, first of all, welcome. How you doing today?
Doing great. How are you?
Doing fantastic. And George, happy you're aboard with us here today as well. I understand you're sort of a rookie at doing this.
Well, a little bit, yeah. I'm happy to be here.
No, that's all right. We'll get you in easy and we'll have a good time. All right. Well, let's just get things started. And Joe, let me start with you. Kind of give us an overview of what we're going to be talking about today when it comes to the advantages of modern piston rings.
Right. So what we're going to be looking at is basically the progression of using modern materials and how that affects both the performance of the ring and actually also the design of the piston.
All right, well, let's talk about some of the advantages of using a modern ring set, and either Joe and or George, however you guys want to, kind of get started covering some of this ground.
Sure. I think, we'll get into it a little bit deeper into the presentation that will be shown here in just a few minutes. But, basically, over the course of time, materials have increased where they are better, and that you can take that technology and apply it to piston rings, in particular pistons as well. Specifically with piston rings, what we'll show is that you're not going to be using as much material, how that affects the performance of the ring, the advantages of that, the benefits of that, and how engine builders that we work with, as well as professional race teams, have taken advantage of that technology.
Oh, that's wonderful. And you said you want to start with the presentation, Joe? Is that the way you want to get going here?
Yeah, I think that's what we could dive into and go that route with it and kind of lay out, kind of who MAHLE Motorsport is, as well as getting into where we can really show with pictures and graphs the way you can, show the advantages of those piston rings.
Awesome. And is that, are you going to share your screen on that, or how will that get going?
Yep. We'll share it right here.
All right.
Just a second here. I apologize.
No, that's okay. The miracles of modern technology allow us to do a lot of things, but also when they work, they're great. When it doesn't happen immediately, it's always frustrating. So I understand. Take your time on that. I'll tell you what, George, while Joe is getting that ready, just kind of give us an overview of what you do as an application engineer at MAHLE.
So I started here about 2 years ago. and I deal with primarily professional race teams. I've been the primary contact between our engineering staff and our customers. And so I primarily deal with custom piston development, and that varies in many applications. I do a lot of like dirt circle track, super late model, sprint car, even drag racing and up to NASCAR. So I do a little bit of everything.
No, that's really cool. And certainly, you know, when you start talking about different racing series, and look, the MAHLE brand has been known in racing for decades now, and obviously is a very well-respected one, which is great. But just to be able to cover various forms of racing and certainly specific needs in each one of those forms of racing as well. You know, George, I would imagine that, you know, when it comes to an engine build for a dirt late model versus an engine build for a NASCAR stock car versus a sprint car and all of that, each one of those kind of has its own unique applications and what the needs are.
Oh, absolutely. Yeah. The technologies employed in each of them are certainly, they're not, I wouldn't say that they're vastly different, but they are certainly specialized.
Yeah.
Just to add to that,
Go
I'll
ahead.
go ahead and share my screen here, and we'll dive into this, and we can look at some of the differences that George works with day in and day out. Can you see that?
We can. Thank you.
Yes, sir.
Excellent. So basically, we will dive into the different, the progression into modern ring technology. But just want to start off first. MAHLE Motorsport is part of MAHLE, and globally, MAHLE has about 71,000 employees with 160 production locations, and it was founded in 1920. And then within that is the North American division of Motorsport, founded in 2000. And we currently have 168 employees. We have 2 locations, our Fletcher, North Carolina sales and engineering office, and then Morristown, Tennessee, where we manufacture and ship product. So, while MAHLE is a large global entity in the transportation market, within that we have a very unique and special division with Motorsport, where we do work with a number of professional engine builders, a number of professional race teams that take advantage of a lot of what we bring to the table. And specifically with that, I bring this up here not to point out, just everybody that's on there, but if you look in parentheses, that is years that these individuals have been on our staff. So if you look at Brad Green, he's been with us for 25 years. Doug has been with us for 37 years and onward. And this is just our engineering department. What that brings to the table is, if you think about everything that these individuals have seen from the evolution of piston design, that's a lot of knowledge. And that's a lot of knowledge that our customers and our race teams that we work with take advantage of. I mean, certainly, over the years, not only just working with the race teams and the engine builders, but also working with OEs and drawing on that knowledge of what is seen there to create, better piston design, more efficient piston design. And then just continuing over here on the sales side of everything with, we have Jason and Dale. They've also been with us for 20 years. Adam has come on to be our tech and has just done a wonderful job with that. And then in addition, starting here next week, we'll have Rob Canaan, and a lot of people are familiar with that name from the years in the industry that Rob has been with us. So he'll be a great addition to strengthen our marketing approach that we're taking in that field. So pretty excited about what we're doing here and the team that we have on staff here. And, as we get into it, just a site here, we also have everybody that works at the Morristown facility, where they do the manufacturing of the pistons. And I will tell you, it's an amazing operation when you do walk around there and see, what occurs, what they are producing. And we've been very fortunate over the last 4 to 5 years to produce more pistons and more power pack sets than we ever have. So been very fortunate, and we have a great team over there that makes it happen every day for us. You know, specifically what we're getting into and what we're talking about are our power pack piston sets, and how that, you know, ring pack, the modern ring pack, has really affected that. So when we're talking about some of the applications today, and you do hear power pack is our high volume piston set line that comes complete with rings, pins, clips, and of course pistons. And they can be, you know, purchased at any major retailer or any major distributor. And we've had a lot of people discover these piston sets, take advantage of its technology that we offer. Our tolerances are so high, and that's something that is often said to us is, you know, when an engine builder does get a set of these pistons, wow, you know, everything is on the mark. And, you know, as an engine builder, you don't want to have anything that's, you know, way out of, you know, a weight difference or any issues like that. So a lot of them have been taking advantage of the high quality that we do offer. And of course, you know, I think a lot of people, when they're visiting different websites, say it is Engine Labs or something to that effect, you know, they do see our advertising. And this is our new Ford Godzilla Power Pack piston set that we came out with this spring. And just wanted to highlight that and just kind of make that connection out there. If, you know, people are online or looking through any of the trade magazines and they see that, that is MAHLE Motorsport. So diving into the specific of what we're going to talk about today is 16th top rings, which is an older technology compared to what we are putting in our power pack piston sets now, which is a 1 millimeter top ring. And specifically what that is a 9254 chrome silicon steel, which is 35% stronger than cast iron rings, unequaled in strength and fatigue resistance. And specifically further into that, we're going to talk with 4 different areas: conformability, better performance, improved strength, and design flexibility. But before we dive into those areas, I think it's important to review and talk about what does a piston ring set do. And I'm going to turn this over to George here and let him talk about the different functions.
Hi, George. Why don't you take it over here and tell us what we're looking at?
There we go. Just took a second to show up on my screen. I think it's important, like Joe said, to understand the actual function of each piston ring, so that we can better explain how our piston rings are better. So you're going to have your top compression ring. That's going to be your first ring that sees any combustion pressure. Its primary job is to keep combustion gases and pressure inside the combustion chamber. And its secondary job, since it is the first line of defense against that combustion pressure, it's also going to see the most heat. So its secondary job is going to be to transfer that heat out of the combustion chamber from the piston into the cylinder wall and then into the water jacket. And it also does play a minor part in oil control, but its minor job is just to keep oil out of the combustion chamber. And so then moving on to the second ring, its primary job, even though it's called the second compression ring, that's actually its secondary job. The second compression ring, its primary job is to control oil. It acts as an oil scraper, and it takes and meters a very fine film of oil onto the cylinder wall that the top ring can then handle. And then that secondary job is to catch any combustion pressure that escapes the top ring and transmit that into the piston on the downward stroke or on the power stroke. And then the oil ring its function is strictly just to pull large amounts of oil off of the cylinder wall. It meters a rough film of oil that the second ring can then control. And so what it all boils down to is the basic function of your ring pack is critically dependent on consistent contact with the cylinder wall, that each ring has consistent contact with the cylinder wall.
So when we are, talking about top ring technology, what you're seeing here in the green is basically a cross section of a 16th ring, and then we have a 1.5 and a 1 millimeter. And the first thing that you notice is the mass, how much less of 1 millimeter is compared to a 16th. And I think sometimes for some people who are not familiar with those rings, they can have concerns that, people will put the word thin out there. The rings are thinner, and that's not necessarily what we want them to say at all. What we want to say is that they're more conformable. If you look at the history of it, the technology of a 16th ring is almost 60 years old. And then you look at a 1.5 and, it's 1980s technology. And then we have 2010s with the 1 millimeter ring. And you're seeing this progression. Why is that? Well, you're working with better materials. You're working with materials that are able to flex more. They're able to conform more to the cylinder wall and perform overall better. And specifically, you're dealing with increased material hardness, higher tensile strength, higher yield strength, and increased fatigue resistance. Not only that, but you're also dealing with an application where you're losing weight, and you're losing reciprocating weight when it's actually in operation. So don't think about the piston and the ring set when it's sitting on your workbench and just lying still. You need to think about it when it's in actual operation. You're taking advantages of that modern technology. You're taking advantage of the ability for it to conform. You're taking advantage of the ability of the 9254 steel top ring to put up with large amounts of pressure, but not have as much mass compared to what you would have with a 16th top ring. Go into a little bit about ring technology progress and how that came about. I'm going to turn it back over to George, and he's going to take us through how that progression came to be.
Yeah, so how did we get here? The progression towards a lighter ring with lower tension that generates less friction is actually driven by professional race teams. And it, in recent years, has been adopted by the OE side, which has a lot tighter and stricter requirements for longevity and durability. So what makes this ring technology possible is the innovation and the availability of stronger and lighter materials to construct the top rings out of. And as current racing engines demand ring sets that will perform under higher cylinder pressures, higher temperatures, and an increased threshold for operating RPM, that's what requires the use of this 9254 steel. So what's the answer? The answer is that the 9254 steel that MAHLE Motorsports incorporates into each ring set that we sell with our Power Pack kits. This stronger material allows for a ring with a shorter axial height and a narrower, reduced radial width, resulting in a ring that has a decreased cross-sectional area and overall ends up being a lighter weight. This aids in creating a more conformable and ultimately a higher performing piston ring without compromising strength.
And then adding to that, that's just the ring itself with that material. Okay. Now we're going to talk about the piston ring face itself. So a lot of times, we'll have people call up and they have mixed up their rings. They've taken it out of their kit, they put it onto their workbench, and they can't tell what the top ring is and what the second ring is, and they'll call up and they'll say, well, one of them has a shiny outer surface. And what that really is, it's a HV 385 thermal spray face coating. It is actually shot at the piston ring face at supersonic speeds and embedded into the piston ring face. Now, what does that do ultimately? Has excellent scuff resistance, increased bond strength, increased overall strength and toughness, quick and consistent break-in and sealing, and it has a low coefficient of friction. Now, talking about the progression of the ring and how we got here, what MAHLE has been able to do is, because we are such a large company and we do sell so many rings, so many pistons, we have been able to make that technology more affordable for the retail customer, to where they can take advantage of that and purchase that from any MAHLE Motorsport distributor and have that right there in their hands and take advantage of it. We've had several come back to us and say, you know, I'll give you an example, was Keith Dorton last month at AERA, and he said, gosh, I really do like those rings. They sure do seal nice. And we just love hearing that. You know, there's a lot of times where we're out there and we're talking to different customers, and, you know, I had a few of them at a conference say, do you have any of those 16/16, 3/16 rings for, you know, a small block application? And as I mentioned before, just going into the whole, you know, presentation that we're basically giving you in about 10 minutes and trying to make people understand that, hey, there's a lot of technology that you can actually take advantage of. And more they're doing it, but there is resistance. And a lot of it is because of what they see. Again, not as much material. Well, there's no way it can put up with more of these pressures, but actually it can, and it will operate better. It will be more efficient, and you will have the benefits of it. Specifically, you know, something that sometimes is overlooked with the cylinder wall is conformability. And I'm going to let George talk a little bit about conformability, what we're seeing specifically with the cylinder wall and the rings.
Yeah, so like Joe said, conformability is a good aspect to have in a piston ring, specifically because if you're looking at your screen on the right-hand side, that graph is actually a cylinder, but it's zoomed in down to a plus or minus 25 micron scale at the surface. And so you'll see that all of these different imperfections or abnormalities in the cylinder, and they vary in location and magnitude. So during operation, this is ever changing as the temperatures, the loads, the pressures fluctuate inside and outside the cylinder. Distortion of the sealing surface is going to be a result. While this distortion is on a micron level, the effect it can have on efficiency and power output is not negligible, especially when it's paired with the wrong rings. With a smaller cross-sectional area that a 1 millimeter top ring provides, comes conformability to these imperfections in the cylinder wall, and helping to mitigate those power robbing effects of this bore distortion.
So, you know, everybody wants to get results. You know, we don't want to have something in theory. We want to have real world results. You know, engine builders, you know, it's a business, but it's also a competition. You're trying to make the best product you possibly can out there. And here's a real world result. And what you see over there on the graph on the right-hand side is increase in performance with both horsepower and torque. And, you know, specifically, why is that? Well, you know, lower tension, less friction, more conformability, more consistency is what the 112 ring pack offers. And what it boils down to, it's just more power. And when you're able to consistently do that over the life of the engine, whatever it may be, you know, it could be short track racing on the East Coast with dirt track racing, or it could be off-road racing in the Southwest. You know, over the duration of that competition, you want to have consistently more power. And that's what a 112 ring pack allows you to do. Further with it, where did this test come from specifically? Well, it was a 2019 Engine Labs article with Bob McDonald. And he goes into great detail about the testing using our MAHLE Motorsport pistons and rings, and going from a range of a 16th to a 1 millimeter, and then showing these results. And the results specifically are a gain of 9 horsepower, a gain of 15 pound-feet of torque over the 16/16 3/16 ring set. And as time has gone on, more and more people have discovered, wow, they really do increase our power, our torque. We're getting better results out of it. The engine, it is performing much better, and it's made our platform stronger. Our customers like it, and we're increasing business. So all of that is a positive on that side of it. Now, I'm going to turn it back over to George and let him talk about something that he deals with every single day, and that is piston design. How do those rings affect the design of a piston?
So like Joe said, I mentioned earlier, I do a lot of custom piston design. That's what I deal with on a daily basis. And I do get guys that will ask sometimes if they can get a 1/16, 1/16, 3/16 ring pack on their custom small block piston. And while it discourages me to hear that, because it actually makes my job harder. Because so on the left, you'll see a cutaway view of a ring package for a 112 millimeter and a 1.5, 3 millimeter ring setup on the same piston. And what you'll notice is the fireland, the material above the top ring is the same height on either piston, and the ring lands are also the same thickness. But what happens with that thicker ring pack is you end up having a gap where the drilling for the pin bore goes. And so it requires a steel spacer rail to bridge that gap to keep the oil ring from slipping out of that hole. And so the shorter ring pack, the 112 millimeter ring pack actually fits better on that piston and makes it easier for us to fit that ring package on multiple piston designs. And another thing that you'll notice in the lower left-hand corner is the actual reduced radial width of the ring requires a groove that's not so deep. And this offers us a little more section thickness between the ring groove and the valve pocket, and actually allows for a deeper valve pocket in some cases. You can go next, Joe. So what this, or another thing that MAHLE Motorsports prides ourselves in is we continually refine our piston designs alongside other technology that's evolving in the industry, such as the rings. And you can see on the left, you'll see the old forging design that we had for our small block Chevrolet dished piston. It was originally designed around a 1.5, 3 millimeter ring package. And on the right, you'll see the new, we'll call it optimized forging design that was designed for use with the 112 ring package. And what you'll notice is there's a lot of excess material left over underneath of that oil ring groove on the gray piston. And so what the shorter ring package allowed us to do was take that material, move it somewhere else on the piston into more critical areas. And it also allowed us to remove any excess material, and overall it netted us a stronger and lighter forging.
What's interesting about that with the small block Chevy dish design is that overall, across the board with the different bore sizes that we now offer in a 2618 alloy, it's actually 29 grams lighter on average compared to the old forging design. So again, another great advantage. We're taking technology that is decades old, and as the engineering staff always does, how do we make it better? How can we make an engine builder or someone who has an engine building company, how can they benefit? How can we make this more efficient? So I think that's just a great example of that and how the rings can really affect the design and the approach that the engineer is going to take to make the final product. You know, just something that I wanted to bring up, since we do have you know, people on here that are probably, you know, wondering what would we recommend for ring gap, you know, and we often have that question come up every week here with our sales and customer service team. And, you know, there are probably, if you were to ask 20 different people, you would probably get 20 different answers. For the motorsport division, this is what we recommend. This is based off of everything that we've seen that has come in for analysis, data that we've gathered. And, you know, if you're out there and you're building engines and maybe you've got, you know, ring gap that you're using from, you know, 2012, we updated this a couple years ago, and currently this is what we recommend. So if you're using MAHLE Motorsport Power Pack pistons, this is on the final page of the application guide. It's also available for download at mahlemotorsports.com. But as you can see, there's a big difference between a high performance street naturally aspirated application and comparing that to a turbo supercharger race application. It's very different. And it's important, you know, take a moment, review that. The instructions also come in every one of our Power Pack piston kits. But, you know, stick to that. Don't be taking information that you're finding online, because oftentimes it could potentially be misinformation. And we don't want to run into any situations where, because of that, your engine is not operating correctly. So just basically in conclusion, you know, what we talked about today with conformability, you know, the cylinder bore distortion, the ring's ability to conform, not only that, but the added strength that the 9254 steel top ring offers, the increase in performance, the increase in horsepower, the increase in torque, and then also design flexibility, you know, allowing the engineers to, you know, take an approach to actually make a better product, because we are using a ring pack that's going to take up less potential area that we showed with the 112 compared to the 1.5, 1.53 millimeter. So all of that are just great advantages that customers can, you know, have right in their hands when they purchase one of our Power Pack piston sets, or if they're doing a custom piston set and they want to take that approach and work with our engineers, it's right there. So just something that we wanted to share, just in our conversations that we have with different customers out there. It was evident that even though that we had made this change years ago to a 112 ring pack, there was still resistance that was out there with some potential customers and that had questions. And if there's any way that we can educate the end user out there, or anybody that's, you know, maybe on the fence of, you know, using a ring pack, the reason why is that the technology is just simply so much better. And with that, we'll just open it up to any questions.
Yeah, definitely. If you have a question, please put it in the chat. I know we've already got one or two there already, which we'll get to. And it's fascinating as you two are going through the presentation, Joe and George. I'm sitting there thinking of all of the questions as well. And, you know, a lot of times when you find performance gains on things, it always comes with a compromise. But it seems like every question that started popping up into my head, you had an answer for. You know, if we start talking about less material on the ring, well, what does that do for strength? Well, you covered that. You know, when it even comes to, say, the ring grooves, you know, not having to be as deep, you know, is that extra weight on the piston? You guys covered that, how much you've saved. And I mean, at least by my math, it looks like that is per piston, between the piston and the ring, about 37 grams of savings per piston as well. And then the durability question, is that, again, when it comes to compromise, a lot of times you make things lighter, smaller, whatever that might be. You might compromise durability somewhere, but again, it also seems like you covered that as well.
Yeah, I just think that, there's a progression towards lighter, faster, stronger. You see that across the board in anything that we're doing, whether it be on the racetrack or internally with the engine. And, we discover all the time, there's different breaking points with that. But the great thing about it, and we were having a discussion about this, yesterday, and it was pertaining to piston pins. And there was a question that was thrown out, and our lead engineer took it and said, this is what you would do. I mean, instantly just knew the answer to something that was a little bit puzzling for us. And again, it goes back to having that knowledge base, having all that experience over the years, and what this team has viewed to, present the best product that's out there. And, we don't want to have any problems that are coming in here or issues with anything, obviously. I used to, when I had a small engine shop out west, I mean, one of the things, customers would always say to me is, hey, I'll see you later. And I would always say, I hope not. I hope I see you when you drop off the engine, and I hope I see you about a year from now when you drop it off again. And, it's the same concept. We want to provide a high quality product that engine builders can use, that they can rely on, and take advantage of the knowledge and the technology that MAHLE Motorsport can bring to the table.
Yeah. A question from the chat. It says, you mentioned heat dissipation is a small part of the job of a piston ring alongside with the sealing. Are there any applications where the heat of combustion is too high for this ring product, perhaps with using alternative fuels like nitrous or something else?
So we do have a lot of customers that use these rings in boosted or nitrous applications. The answer to your question is yes, there are applications where this ring is probably not the correct ring to be using, but to get to that point, you're looking at probably 2,000 plus horsepower. I mean, a lot more horsepower than anybody's going to be using or looking for out of a power pack kit. We'd be looking at something more custom. And for applications like that, there's, a gas nitrided steel ring, which we also offer. But I have customers that use these in mid 4-digit horsepower applications they love them. They're predictable. They work right out of the box. And that's why they keep buying them.
Mm-hmm. Does this impact what, like weights of oil or anything like that? When you're talking about having the different rings and what you just covered?
Not to my knowledge, no. I deal primarily with just piston design, but for whatever weight oil you're using for your racing application, I think this product is going to control oil better, especially when looking at the imperfections in the cylinder surface. So I don't think that changing oil viscosity is necessary, no.
Mm-hmm. How far can ring design go to become more efficient? And is there a cost associated with that?
We do get this question fair amount. And the answer is theoretically, yes, there is a limit. But as we've kind of seen in this presentation, that limit can change, or that limit is ever changing because of the materials that are used to make piston rings are constantly getting better. But is there a cost associated with that? Absolutely. Because certainly we haven't stopped at, a 1 millimeter compression ring. There's stuff out there that's half that thickness, but it costs 10 times, 20 times as much because it's not commonplace in OE use, and there's not as many rings being made for those applications. So it's exponentially more expensive, but they are out there. Yes.
Well, and the other thing too, when it comes to cost, is you had talked about in the presentation that a 9 horsepower advantage, an advantage of 15 more pounds of torque, which to me is a big deal. And then when you start talking about the cost per gain, sometimes you can spend a lot for very little gain, and sometimes you can spend just a little more for a lot of gain. When we start talking about the power pack and all of that as compared to, say what we're used to or what had been traditional over the years and all of that, for me and Joe or George, maybe one of you can answer this better. It seems like that's a pretty efficient cost for a really decent gain.
Well, I think George would agree. It is. I mean, certainly any time that you can go to, the track or, the drag strip or open course, off-road racing, and you have the ability to have something that has more horsepower than your competitor, and it's all simply because you're taking advantage of new technology or modern technology that is out there, it's a no-brainer. And, we have seen it across the board. Land speed, same thing with that, where our customers come back to us and they say, you've given us a great platform to where we can make more horsepower and make more torque. Our customers are extremely happy with, what is going on at the track and the results that they're seeing. And, when the engine builder benefits, obviously it's going to gain business for him. So it's just a simple application of taking advantage of modern technology, applying it to, the business you might have if it's engine building, and then seeing the results on track. And I think, George, you deal with that day in and day out, talking with your customers, especially when it's coming back from the results they've had at the track.
Oh, absolutely. I've got guys that use these in, 800-900 horse dirt late model applications, and they love them. I'm actually refurbishing a used NASCAR engine at the moment, and this is the ring set that I'm putting in it. So if that tells you anything.
All right. So now I have to, what does that go in, that engine? Does it go back into a stock car or something else?
No, it's an engine that I bought. It's actually going in a 70s muscle car. I've got a 73 Plymouth Duster that's going to be kind of a drag and drive type car. And I've been looking for something that's lightweight and makes a lot of power. So, and I work with quite a few of the guys that develop these engines. So I'm well connected in parts availability and different aspects like that. So I'm taking full advantage of it.
That's really cool. How about break-in period? Does this have an impact on that when you're doing a rebuild or building a new build?
Go ahead, George.
Okay. So the break-in period, these rings with that HV385 face coating, they break in very quickly. We do have a break-in procedure that we will provide to anybody that's interested in seeing it. But it's similar to a traditional break-in period, running the engine at under load for 15 minutes at varying RPM, and draining the oil, changing the oil. And but the cylinder surface that these rings require it's not exotic. It's a finish that any machine shop should be able to achieve. And we have those specs too if anybody is interested. But these rings are very consistent. They break in easily, and once they're broken in, they're sealed up. There's very little crankcase pressure that they'll generate.
You know, George, you had mentioned talking to people about custom applications and different things like that. If I feel like I might have some type of specialty need and I'm really interested in this product, what's the best way to go about that?
So we do have an email that you can email us at. We do data sheets out on our website. If you want to submit us a data sheet to tell us what you're working on, just to get us some more information. I think, Joe, that email is motorsport.tech@mahle.com.
Yeah, that is correct. Yeah. So if you did want to go with that approach to it on custom pistons, motorsport.tech@mahle.com. You can visit us at MAHLEmotorsports.com or call us if you want to just get a direct consultation, 888-255-1942. You know, one thing that we always try to stress to everybody is your application is specific and unique to what you're doing. So I often tell people and stress to them, don't go off something maybe you see out on the internet. Okay, you know, call our engineering department, you know, email our engineering department, talk with one of our techs. We have all that experience that's right there, and we can ask questions, you know, that across the board we would ask to anybody and start, you know, picking away at these different advantages or disadvantages that your application may have to paint that complete picture, so that way you can have the best product in hand to then put into the engine.
Yeah, I would say there's always a huge gap between that sounds right and I read it on the internet to here is the actual technical data from, you know, people with advanced degrees and engineers that actually design these products. So I would lean more toward that side with the engineer. Joe, George, this has been fascinating. It's great to talk about technology. It's great to talk about new things. It's great to talk about things that are going to help people go faster. And we really appreciate y'all coming on here today.
Thank you for having us.
Thanks for having us.
Thank you very much, Joe and George, and great presentation. We pushed MAHLE's Motorsports product back on the homepage of EPARTRADE, so please go on the platform, connect and engage with Joe, George, and the entire team through the platform. It's right there for you. We build it for the industry. It's open 24/7. So thank you for being with us today. We will be back live next Wednesday. We're going to bring a new suppliers that's recently joined us, Boostane, and we're going to be talking octane and oxygenation. So thank you very much for being with us. Please, again, you know, go on EPARTRADE for MAHLE. You'll find all their product and latest stuff out there. Thank you very much for being with us, and let's go racing. Bye-bye.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck. and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
My name is Shadron Sisson. I'm one of the owners of Electrified Garage. So the Shop Monkey software is great since we have the multiple locations. We can dive into each other's location and help out with appointment taking, inventory, customer communication. I can jump into Florida and help out and make an appointment down there, and vice versa. They can make appointments down there for us up here. And then by using our inventory, they can see if we have the parts, and they can get the parts ordered before the customer even comes up here.